Hello everyone, my name is Stephen, currently final year student at Middlesex University. So in this video, I'll be talking about designing a hip implant with porous structure. So in this video, I'll be talking about the success criteria, the project development, the testing, and the porous structure evaluation. All these topics will be spoken throughout the video. The success criteria for this project is that, as we know, currently most of the commercial available stem of the hip implants are solid, without pore structure. The shortcoming of this design is that the implant is much stiffer than the surrounding bones, leading to stress shielding. A pore structured implant would potentially solve this issue. Additionally, a porous design would allow bone growth into the porous structure to design a functional porous stem. We need to access which kind of porous structure provided the best results, i.e., in the stress and strain of the bone, similar to healthy people, and the stem is strong enough to bear loading. This all is done throughout biomedical analysis. The loading which I'll be using is 2000 newtons due to the weight of an average human person. In this part, I'll be explaining my designs which are created on SolidWorks and how I started and how I develop throughout. So in my first design, I designed a implant with the stapler component, plastic liner, the femoral head, and the femoral stem. However, some of these components are not going to be used in my test, which means that I have to redesign and make it to the correct one. In this design, as you can see, I took out the stapler component and the plastic liner, and all left is the femoral head and the femoral stem. This is because on the testing I will not be considering the other components, and in this, as you can see, I can do the load straight onto the femoral head without being disrupted by the stapler component, because I wouldn't be considering that in my test. I will only be considering the femoral stem, which in this project is what I'll be analyzing. This is my final design of the femoral stem. As you can see, no extreme detail on the stem. It's a plain stem. I'll be talking about how the testing went for this stem when I did the FE on the simulation using SolidWorks. In this part, I'll be talking about the testing and how I managed to get the results for my stem using FEA on SolidWorks. The results shown are for my static analysis using the FEA software on SolidWorks. As from the results which I gathered using the software, I managed to see that the stem that I created is is not weak, it's strong in terms of it can bear the loading which I used, which again is 2000 newtons, and it doesn't seem to show any break points at all on the stem, which means it's a good stem to go ahead and do the pore structure. In this part is my results for the displacement for my stem. In the upper part of the stem, the femoral head, we notice that it has a bit of an impact due to the weight I used of 2000 newtons, so this could be something to take into consideration. However, on the lower part of the stem, I noticed that is more secured, meaning that the stem itself is much more stronger than before. In my last test, I gathered the results for stress and strain. So these are two building blocks of structural analysis. They are what we use to understand where a component is in relationship to the material failure. So in my stem, I noticed that it's strong throughout. However, on the lower part of the stem, I get a greenish color, which could indicate a slight pressure. So, because I used the 2000 newtons, I could get that slightly green, or the way that the model was done through meshing, it could be that I happen to get the greenish color, but it's nothing major. It's more to be considered um, slightly if I was to carry out more tests throughout the stem. Lattice structures show good potential for the design and fabrication of porous orthopedic implants. Porous structures have lower stiffness than the bulk counterparts, which can reduce stress shielding and improve the mechanical compatibility with bones. In other words, the porous structure or porous coating is is used for bone growth inside the human body. This is my porous structure evaluation for my given femoral stem. As you notice, we have some objects or shapes, let's say, on the stem. These objects are for the porous structures which I created using CAD. The shapes that are shown on the screen is a hexagonal shape which I consider to use throughout the implant on the given area to get the result for the porous structures. I also would be considering squares and triangles to get the results and seeing which of the objects would be best to use as a porous structure on a stem. This is the design which I carried out using CAD, and the hexagonal seems to be slightly stronger should due to the spacing and um, slightly, let's say, object itself, how it's gonna be done on the stem. However, there is a slightly problem due to the design of the stem. I got some a bit of an errors in the meshing part of the work. I could be considering to change the object and make it another shape. However, when it comes to the whole adapting to the whole stem, it doesn't really give me an accurate result. So, as from other users or other people that have created this, we notice that they have a coated layer on top of the stem. However, what I'm doing is I'm creating the porous structure directly to the stem itself. So it's two different parts which I should be analyzing. And yeah, so this is my final porous structure design, yet to be finished and analyzed. Thank you for watching my video. I hope you enjoyed.